Okay, I think we can kick things off. More people may be wandering in as we go along. I'm Joe Barron, another solutions architect, and I'm going to talk about storage. So you've probably seen throughout the day some variation of this slide with our kind of infrastructure building blocks at the bottom, our higher level services built up on the top of that. The reason I want to show you this is that if you circle the ones that are storage or have a strong storage component, it's pretty much all except the network layer on the infrastructure layer and quite a bit above that. So storage is pretty pervasive in this environment, and it tends to be a little bit different from storage in your traditional environments and can be a point of confusion for some of our customers. Another thing that you've probably seen multiple times throughout the day, but just a reminder, essentially each cloud, each region is a separate cloud. You put data or resources in, they don't move, and then within each cloud region we've got multiple availability zones, fault isolated kind of abstracted data centers, if you will. And the reason I show this is that each of our storage options in some cases has availability and sort of lives at the region level. Others live and have durability at the level of an availability zones, and others are things that live within a single instance. And it's important to understand the level of durability, where your storage lives. So if we look at the traditional kind of storage hierarchy, there's multiple ways to attack this, but I'm thinking of storage in the sense of a place to put data. So abstracting storage from more than just spinning disks. And in that case, we have from very, at the high end, very ephemeral storage in memory, like caches and RAM disks and that sort of thing, down through direct attached storage and network attached storage, SANs and LUNs, all the way down through very, very durable offsite backup, kind of archival and backup storage. And in between, you've got multiple dimensions of whether it's block storage or file storage, whether it's structured storage that can be queried, the database kind of thing. But basically, there are multiple ranges of storage, multiple kinds of storage you would use in any typical application infrastructure, any architecture. There's performance elements, there's durability, there's cost, there's various other aspects. And you tend to choose them and mix them and not just say, all my storage is going to be on the SAN, or all my storage is going to be file storage, NAS-based. You use it in a hierarchy, and you do that in order to get the kind of performance that you want and the kind of durability for data. And if you look at an item of data, it's going to move through your hierarchy over time. So if we look at cloud storage, it's very much the same story, but of course we changed the names just to confuse everyone a bit. But in every one of those categories, we've got an offering in the platform. And in many cases, there are multiple options beyond this that come from open source software or from some of our solution providers. What I'm going to highlight today are the things that are built into the platform and are available as part of the platform primarily. So just running down the list, on the memory side, we have a caching service, relatively new offering, Elastic Cache. Direct access storage, the analog of that in our case is the EC2 instance store, the storage that's in the box, if you will. SAN and NAS, basically network attached storage. We've got an analog of both in Elastic Block Store for sort of the SAN, and NAS, sort of a rough equivalent for a file-based storage. We have Simple Storage Service. Moving into structured storage, we've got multiple options there if you need, and we'll sort of generalize the idea of a database into storage that can be queried. So we've got people running their own database, EC2 database AMIs. We've got a relational database service where we'll run it for you, and we've got SimpleDB where you kind of get a schemaless database without any operational overhead. And then message queues, we've got kind of message-oriented middleware for the cloud. Onto backup in archival storage where you've got options in both the EBS side and the S3 side. So again, like that traditional hierarchy, all of these differ in their performance, their durability, their cost. They also differ in things that are sort of more cloud-like attributes like their elasticity, their scalability, their durability in the cloud sense. So the key point is that when you create an application hierarchy in the cloud, you should, again, use multiple options and have your data move through a hierarchy over time. So what we're going to do today is kind of examine each of these major categories of storage. I'm going to kind of give you the ideal use case and the characteristics for each piece of storage. And in many cases, at least for the big items, we're going to give you kind of the anti-patterns, where you would we'll give you the ideal case and we'll give you the anti-pattern where you should not use it, where you should use something different. So starting from the top in that same kind of hierarchy, one of our newest offerings on the memory side is Amazon ElastiCache. And this is basically Memcached as a service. Someone out there has said that Web 2.0 is basically memory. Anything that is super high scale web application, in many cases the storage of record is actually memory. But even if the storage of record is not memory, there's a huge amount of memory caching. And most of that is running in some flavor of Memcached clusters. So what this is basically us running Memcached for you. All you really have to do is choose the amount of memory, calculate the number of items that you want to store, how much memory would that take, choose an instance size out of our EC2, and we will spin up the right number of instances to give you that much caching memory. We'll manage the health of those and automatically detect when one goes down and spin up a new one for you. So it kind of takes the administrative burden away from you, and you get a push-button flavor of Memcached. The price is a very small sort of surcharge on top of our standard EC2 instance prices. And ideal use case for this is basically taking the load off of a database. And this is in many cases key to scaling in the cloud. In the cloud, you often don't have the option of running an enormous single-scale database. For example, we don't have a 48-core instance with 500 gigabytes of memory. We don't have SANs that will scale to thousands and thousands of IOPS. So in many cases, caching is the key to database performance, is actually shedding load. So there are many things that will actually build on top of Memcached. So you can use it as in front of the database. You can use it as a page cache or a session cache. So it's very, very useful. It also sits in front of, as a drop-in replacement, sits in front of many of the common content management systems. So Joomla and WordPress and Drupal. So moving on to direct attached storage. The equivalent of direct attached storage, meaning DASD, or disk that is in the box, in the server itself. The equivalent for us is what we call EC2 instance stores. They're also, we've over time called them different things. They're referred to as ephemeral drives or local drives. But basically this is in the box storage. It's on the hosting server where your guest lives. It's not network attached. So the good parts of that is that it's free. In other words, its cost is built into the base price of the instance, and there is no network variability since you're not using the network to get to it. The bad part is that there is no persistence. When your instance goes away, when you shut down your instance, all that storage is wiped. So it's like local storage in the sense of, it's like a local disk in the sense of a physical server, but when you turn off your physical server, the storage doesn't go away. In this case, when you turn off the server, it is all gone. So this is storage that I would say use at your peril, use when you know exactly what you're doing with it. So its ideal use case is basically data that has no need for strong persistence. For scratch disks, for staging area, temporary buffers, caches, that sort of thing. It also is ideal for data that is replicated sort of by default. If you have a set of auto-scaled web servers, and you're going to put data in the doc root, and it's replicated in every one of these instances, the ideal place for it to live is in the instance store. So this varies based on the instance type. On our smallest instance, a micro instance, there is none of this. There's too many of them per hosting server to have access to local stores. And if you go up to our very largest HPC class instances, they have a 1.8 terabytes of local storage. So the number varies. It can be 0, 1, 2, or 4 drives, depending on the instance type. And in many cases, it is available to you, but is not exposed by default. And we'll go into this a bit in a moment, but on our EBS-backed instances, the ones that boot from network storage, we don't expose the local instance stores. So if you choose, you can get at them, but they're not there by default. And this is really not optimized for random I/O. It is very good at streaming. Like any of our block level disk options, it can be striped in a RAID array. And if you do that, you can aggregate both IOPS and streaming performance as well. So the anti-patterns for this, basically anywhere that you don't want the instance store, you probably do want EBS storage. So anything that needs strong persistence, where you want a backup capability that's built in, you want storage that you can unplug from one instance and plug into another instance, all of those kinds of things, you basically probably want EBS. And I'm not sure I mentioned it up here, but if you have, if what you're looking for is random I/O performance, EBS will actually do better as well. So next class of storage is network attached storage. And in this category, we really have two major items. At the block level, we have what we call elastic block storage. This is probably the most important class of storage that we'll talk about today. This is really block level persistent storage, virtual disks for your virtual servers. And the key thing, what's different from the local instance stores, is that the data is persistent and its lifetime is independent of the life of a virtual machine, a virtual server. So you can treat these, they act very much like a physical hard drive, like a typical eSATA drive. They have performance characteristics very similar to an eSATA drive, and like a SATA drive, you could plug it into one server, put data on it, unplug it from there, put it on another server. So it's sort of portable within an availability zone. But it's really network attached storage. It's not network attached in the sense of NAS, it's network attached more in the sense of a SAN. Although under the covers, this is not, we're not giving you access to a classical, iSCSI SAN or a fiber channel SAN, but this is off-instance storage. So there is some network variability associated with using it, and you can attach multiple volumes to your server. So you can do sort of best practices things where you will attach, put a database together, you'll put logs on one volume, you'll stripe your data volumes across multiples in a RAID 0 array. You can do all of those kinds of things. But you cannot, this is not sort of implicitly shared storage. You cannot have one EBS volume mounted to two virtual machines at the same time with them both writing and reading data. This is one server at a time. The cost is a flat 10 cents per gigabyte a month based on the provision storage. So if you say, I want 100 gigabytes, you're going to pay for 100 gigabytes of storage, whether you're actually putting data in it or not. It's based on the size of the drive. And it's really just based on an aggregate total. If you pay, it's the same price for one 500 gigabyte volume or 5 10 gigabyte volumes or 100 5 gigabyte volumes. So all we care about is the total aggregate. There's no per volume cost. And really, the ideal use case for all of this is primarily for your OS and boot device. So most of our newer Amazon machine instances will be this kind of storage. They will boot from this. So it's your root file system. It's also for anything that has a persistent file system or a database, or anything that needs a raw block device, like a logical volume manager or Oracle ASM, that sort of thing. So as we said, this is durable off-instance storage. So the durability is there by dint of having two copies of everything. Under the covers, what we do is give you a mirrored pair of disks. So the durability then is better than what you'll get out of an off-the-shelf, eSATA drive. So performance characteristics are like that. Durability is actually better. And then if you actually use our snapshotting service, which gives you a point-in-time backup, we then have two copies in the mirrored pair, and we have a third copy in very, very durable S3 storage. So this really enhances the durability of the whole system. So these disks are really within an availability zone, and if you have less than about 20% of dirty data at any given time on a volume, you should expect somewhere between 0.1 and 0.5% annual failure rate on a disk.
So can you partition these into multiple partitions for the different file system?
Yes, I mean at the OS level?
Yeah.
Yes, you can, but in many cases there's no real reason to do that. It may be just as easy to create separate EBS volumes for each file system. But you can. Yep. Yes? Yeah, oh, I'm sorry. The previous question was, can you put multiple file system partitions on a single volume? The answer is yes. And your question was, can you resize? Yes, you cannot resize a running volume, but if you have a volume that is 50 gigabytes, you decide that it really needs to be 100 gigabytes. What you do is you take a snapshot of that volume. From the snapshot, you create a new volume and you make it be 100 gigabytes in size. Then you detach the old volume, attach the new one. So it's not a transparent, but it is a fairly simple and quick process. So we covered the durability side of this. These disks are really optimized for random I/O. So if you think about this was put there for both file systems and in particular for persistent storage for databases, and we optimized it for small random I/O. But you should expect is about 100 IOPS in those small random I/Os for each disk device. So they're not sort of speed demons, but they're like a single E-SATA drive would be. But you can aggregate IOPS by raiding these together in RAID 0 environment. It does not tend to be worth your while to go to higher levels of RAID because we've already got that sort of RAID 1 mirroring built in. I think we covered everything in there. Yes?
Can an operating system instance talk to storage in two different access areas?
What do you mean by two different access areas?
We have the regions together, access A, access B, access B.
The EBS volumes are really limited to a single availability zone. So when you spin up a server, it lives in one availability zone. The EBS volumes live there as well, or need to live there. You can replicate across zones, at the OS level or the application level. And for asynchronous replication, you can even replicate across regions. But the disks themselves live within one availability zone. Snapshots, however, live at the region level. Yeah, so in terms of disaster recovery, sort of high availability, you would do within one region by using multiple availability zones. And then disaster recovery, you would tend to do between regions. So anti-patterns for EBS are kind of obvious. If you've got temporary storage, you might want to use the on-instance storage and not pay the cost of EBS. If you need more durability than that mirrored pair will give you, you either want snapshots or you want to store your data directly in S3. So the difference is that the design point for S3 is really 11 nines of storage. It's very, very high durability because we're copying that object in multiple locations. In EBS, we're copying the object in two places within an availability zone. So again, if you are storing static web content, that's kind of an ideal use case for S3 that we'll talk about next. And if you're storing structured data, if you don't want the overhead of actually building your own database and managing it, we've got SimpleDB and RDS offerings that we'll talk about in a moment. So this is a good point as any to talk about another sort of point of confusion. We are a golden image-based cloud environment, so you spin up a virtual machine, a virtual server from what we call an AMI, or Amazon Machine Image, and we have two flavors. One will create an instance which only has instance store temporary storage. The other will boot from an EBS volume. If you boot from an instance store volume, by default you only have this temporary storage. When you turn things off, everything in your root volume, if you've configured software on your instance, you've created users, that sort of thing, it will all disappear. What you can do is create and attach separate EBS volumes. But by default, if you use the other flavor of AMI, a boot from EBS AMI, that storage is persistent. And you can treat the AMI differently. You can start it, you can stop it. When you stop it, you're only paying for storage. So I would recommend that for most use cases, you use the EBS, the newer EBS root AMIs. Yes?
So if you terminate an EBS root machine, then the EBS goes away?
By default. The question was if you terminate an EBS root volume, does the storage go away? The storage goes away by default. So when you terminate, you're saying, I don't want this machine anymore. If you stop it, you're saying, I'm going to restart it again tomorrow. You can change that by setting a flag says do not delete on terminate. So the behavior is under your control. Yes?
If I, instance this, and I need to go up, let us say, a partial web server, when I turn it off, so the first case, you have to install it again.
Yes.
And the second time
it persists, yes. Okay. So the question was on installing Apache. In the first type of instance, it will disappear when you turn it off. The second type, the installation is still there. A question? So moving on to the second flavor of network attached storage, it's another of our sort of big items in the zoo here. Amazon Simple Storage Service, or S3. This is extremely durable and very simple data storage for the cloud. So it is sort of NAS-like in that it is a file-based storage mechanism, but it really talks HTTP. It's a web-based, so you talk to it via HTTP puts and gets rather than POSIX reads and writes. You can read and write objects from a gigabyte in size or a single byte in size up to 5 terabytes in size, and it's meant for very high concurrency, very high scaling. So it's really useful for almost any kind of data. And this is kind of pay-as-you-go pricing like everything else we have. This is a little bit more expensive than the EBS storage, and that's because we're actually storing more copies than we do with EBS. It's part of the durability. The ideal use case, the very simplest use case for this, is static web content. Every object that you put in S3 storage has its own URL. So by simply changing and moving your storage into S3 and then changing the doc route, the sort of link pointer in a web site, you can actually offload all of that content and all of the service of that content to S3. So the web content will be delivered directly out of S3 rather than through your web server. The question was the inherent redundancy, is it unlimited? The redundancy is, you can think of it conceptually as we store 3 copies throughout a region, and that gives us that sort of 11 nines durability target. And it's unlimited in terms of the amount of data that you can store.
So the 3 copies are in a different availability zone, or are they?
Yeah, conceptually, yes. It's really, those are details kind of under the covers, but that's the only way to achieve that kind of 11 nines target, is to have the equivalent of 3 copies.
Because the West Coast region has only 2.
That's right. There are places that are only, but availability zones, we don't say 3 availability zones, we say in multiple locations and multiple servers throughout a region, is a kind of our official wording. But what we're doing is, in effect, storing 3 copies in separate facilities. So in all cases, even in regions where we only have the 2 availability zones. So characteristics, this is a very simple kind of offering. It's a 2-layer hierarchy. You have buckets and objects. So think of a bucket as kind of a web folder and an object as a file. Every file has a unique URL. If you want that URL, that file name, to be multiple slashes that look like folder, 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 file, this will reflect that, and you can actually navigate through it as if it, but it is really just that single level hierarchy. It's just a unique name. This is the durability is we've really talked about. Gives you that 3 copies kind of level of durability. If you don't quite need that, if you're storing, for example, image thumbnails or something that's easily replicated, we have a reduced redundancy storage option, kind of a check mark, and you can get a lower level of durability at a lower cost. So this is really meant for extreme scale. It's extreme scale in terms of the number of objects. You can have an unlimited amount of data. There's no limit on the number of objects per bucket. And there's no real limit to the number of concurrent reads and writes into a bucket. We will, under the covers, we will scale it as necessary. So this is used for many of our largest customers for directly web accessible content, and is really extreme scale built in. Yes?
If I use S3 to store my data, so I don't have to worry about the setting, right?
Yeah, you don't have to worry about the failure. We will actually manage the redundancy among the copies. We'll compare all the copies to one another, repair any lost data, if you will. So it is it's extreme durability storage. Where you might not want to use S3 is where you actually do need a file system, where you need very fine-grained access to data, where you're going to access parts of a file and change it at very high rates. This can be made to look like a file system, but it's really a web object store. So its latencies are more characteristic of the web. You kind of put a whole file, get a whole file, and it's kind of 100 millisecond time frames, not the 10 millisecond time frames you might be to get a block of a file. So if you need rapidly changing data, or if you need structured data, it belongs somewhere else. Either use it in conjunction with a database or SimpleDB. If it's rapidly changing or you need a POSIX file system, you probably want that on EBS.
Can you add ACLs to the object?
Yes, we have, I think I'll talk about this a bit later when we talk about backup, but on the bottom we have multiple ways of giving you access. There are basically 4 layers of access control. There's a simple ACL on an object. Then there's a bucket policy, which gives you fine-grained rules you can apply to everything within a bucket. You can do the equivalent things using identity and access management policies on a user or a group of users. And then we have a way of giving you expiring URLs, so very short-term access to data. You can also do encryption in transit and at rest, and we support versioning for protection from inadvertent delete. So something that's used very commonly in conjunction with S3 is our content delivery network. And again, this is kind of a checkbox. You say, I've got data in S3 and I want to deliver it via a content delivery network, edge caching. You can very easily do that. It supports other origin stores besides S3, so you can point it at a web server in EC2 or a web server in your on-premise environment. But same concept. The real use case behind this, the ideal use case, is that if you want the fastest delivery, both in the bandwidth and the latency sense, at the lowest cost, our CloudFront Content Delivery Network gives it to you. The reason is that it's, in general in the cloud, you don't pay for data into the cloud, you pay for bandwidth out. The lowest cost for bandwidth out is this 12 cents per gigabyte starting point, which is lower than the equivalent for S3, and it's also tiered much more steeply. So it's kind of the best of all worlds. You get the highest bandwidth, the lowest latency, and the lowest cost. Now moving on to another class of storage, structured storage, meaning databases and the generalization of a database, data that you will query. The simplest offering that we've got there is for cases where you need the core functionality of a database. You need to put and get structured data and query structured data, but you don't really need all the capability of a relational database. This is basically our NoSQL offering. It's non-relational in that it gives you some of the function of a relational database, but not the full. It doesn't give you joins, and it doesn't give you full complex transactions that cover more than a single row, if you will. But it does support a SQL-like select language. It supports SQL-like queries. And it's kind of, if you don't need complex joins and complex transactions, this gives you a lot of the functionality of the database without any management overhead. It's more like managing a spreadsheet, if you will. Very, very flexible. If you have DBAs, you can make them more productive. If you don't have a DBA, you can probably get by without one. Another interesting aspect is that for many people, the use of SimpleDB is free because we cover up to a gigabyte of data and about 2 million queries free. So it can be used for many sort of lightweight database-like applications without any cost at all. So common use cases is metadata storage. You've got data that you've stored in S3, but you want to query against it. So you put the metadata in SimpleDB, you do queries against it, and you retrieve the objects from S3. So just some characteristics, comparing it to a relational database. The analog of a table is a domain, of a row is an item. Roughly, the analog of a database column is an attribute, but you can have as many attributes or as few attributes on any given item as you want. That's an aspect of this sort of no schema required. And then values, of course, are values. So for many things, this can substitute for a database, can give you very high-speed access to your data without any really management overhead. If you need some level of sort of transactional updates, we have a read after write consistency option, and we have the ability to do conditional put and delete. So it's almost a sort of a test and set operation in storage. And it lets you implement things like counters and sort of single item transactions, if you will. So anti-patterns here, basically if anything, if you need the full capabilities of a relational database, if you need anything that SimpleDB does not do, you probably want RDS, or Relational Database Service, or you want to run your own database on EC2. Question? The question is, do we have a kind of a standard driver level or tier like ODBC for this? And the answer is no. It's basically a RESTful API, a web services-based API. But there are many libraries for available languages that build in kind of base level stuff. So kind of give you the equivalent function of ODBC by giving you a library level access to it.
So the results come back as JSON or XML or?
The results come back as a set of, it's sort of like JSON, but it's not exactly JSON. It's basically a set of key value pairs. Moving up the stack again, if you do need a true relational database service, we'll offer you one as a service, a fully functional MySQL or Oracle database, where we will run it for you on your behalf as a managed service. And so we'll automate, basically you will choose how big a database you want, how many cores and how much memory you want on the instance that will run it. Then we'll actually provision it for you. We'll do patching, we'll do backups. We'll even do advanced functions like replication for read scaling and failover. And all you really need to worry about is pushing the button and getting a connection string back. So the cost here is, again, very, very small surcharge on top of the basic cost of the instance. So our instances run from, I think, 8.5 cents an hour roughly to about 220 cents an hour, $2.20 an hour. And everywhere that I give prices, they are sort of approximate and East Coast based. Our prices vary a little bit depending on what region you're in. But just to give you a ballpark, you're paying basically for the instance that you're running on plus storage, and very, very little more for all of the automation benefit.
That gets your Oracle license,
Oracle, actually didn't think about that. Oracle prices are probably a bit higher than that. Greg, do you happen to know? But the Oracle license is built into the cost of the instance. It's all there on our page. With Oracle, you actually have two options. You can pay for the cost of the license by the hour, or you can bring your own license with an enterprise agreement. So this is really, it's exactly what you would expect it to be. It is MySQL 5.1 or it's Oracle 11g. The only thing that you don't get is you don't get to log in as root. But we give you, through what we call parameter groups, we give you kind of the ability to control most everything else that you would want to control, and all of your normal applications and tools would just plug in and just work. So very, very simple, push-button deployment of a full relational database. You can give for test and dev environments, you can give every developer their own database. Again, if you've got DBAs, you can make them much more productive. If you don't have DBAs, you can probably get by without them in this environment. Some of the cooler parts of this apply at this point in time only to MySQL. We will do read scaling by giving you read slaves up to 5, again, just on a push-button basis. And if you want what we call a multi-AZ deployment, we will actually do synchronous replication and do failover by setting up a database primary in one availability zone and then a slave database in a second zone. We'll do synchronous replication between them, and if the primary fails, or if you choose to fail it over for maintenance issues, we'll transparently swing everything over to the slave in about 30 seconds and continue. So you get, as part of this, you get, within a retention period, you get automated backups. So we'll do daily backups. We'll keep them for 8 days. And then, I keep hitting the wrong button there. And we back up the database as well as logs. So you get a point-in-time restore capability on 1-second boundaries within that 8-day retention period. Then you have a second mechanism where you can initiate a database snapshot on your own and then save those for as long as you want. So this really gives you very, very kind of push-button management capability for a database. Very, very slick offering. The Oracle offering is a little bit less robust at this point in time in terms of features. We don't yet have the advanced replication features built into the Oracle side, but that will come over time. Yes? 1 terabyte is the maximum size per instance. So anti-patterns are kind of obvious. If you've got very simple data that doesn't need full capabilities, you might want SimpleDB. If you've got not exactly an anti-pattern, but if you're using a large amount of binary data because of things like that 1 terabyte limit, you might want to put the binary data in S3 and simply use RDS as the query capability. If you need to go beyond the limits of our largest instance and the amount of data that you can put on it, you need to scale vertically, then in our environment, in the cloud environment, you're probably in a NoSQL environment. Yes? Okay. And lastly, if you need the full characteristics, full control of a relational database, you probably want to run a specific database yourself on EC2. So moving on to this sort of last category, if you need full control, just about any database known to man probably has an AMI ready to use and available on EC2. So that includes all the big vendors, Oracle, IBM, Informix, as well as things that are coming out of the open source community or sort of, more niche products, column-oriented databases like Vertica. And in this environment, very hard to say. Cost and license terms really depend on how the vendor chose to do it. Where you want this is where you've got an application that is tied to a very specific database that is not either MySQL or Oracle, and you need full control. So I think we've really spoken about almost all of that. So in the charts, there's kind of a summary chart saying what you get with SimpleDB or the relational database service and your relational database AMIs. Kind of control and level of administrative overhead both increase to the right, if you will. So moving on, message queues, kind of some people would question whether this should be included in a storage. But if you think about it, this is very, it's reliable but temporary storage for data. And it also avoids the use of other forms of storage. So this can substitute for using a queue or a cache on disk. And it's used very much in the sense of a storage tier. So this is our SQS service is basically message-oriented middleware rethought for a cloud environment. And again, very much like SimpleDB, for many people, it's a free offering. The first 100,000 requests are free, and they're very inexpensive thereafter. So the primary use case, the ideal use case for this is to do soft coupling in the cloud. Create your applications as a series of black boxes, connect those black boxes via SQS queues. And some of our biggest customers do this to sort of cloud enable their applications, let multiple tiers scale independently. This is one of the things that Netflix makes a great use of. Both SQS and SimpleDB. And they often work together in conjunction with S3. So you're storing the actual data in S3. You're storing some metadata about it in the queue to say, do this work against this data that I pointed to in S3. Very easy to do loose coupled applications that way. So limitations here, it's meant for text only. There's a limitation in the size of the data and a limitation in the time they will stay in queue. But while they're there, they are replicated in multiple locations throughout a region, so very, very durable but temporary. This is meant for extreme scale, so it supports an unlimited number of clients reading and writing in a queue and an unlimited number of messages in a queue. The flip side of that coin is that it's really not designed for single-thread maximum performance. It's going to give you somewhere between 5 and 50 messages per second. And a lot of people will look at that and say, well, I could run RabbitMQ or something like that and get a much higher rate. Well, if you turn down all the durability characteristics that would be necessary to be the equivalent of this, you would probably get down to that same level of performance per stream. And the answer to it is that you really want to have parallel access to get the most benefit of this.
So that's more like a topic rather than a queue. I mean, multiple clients can subscribe
Yes.
to the messages. It guarantees delivery to all the clients that are.
No, it guarantees. We have an offering that is like that. So the question is this more like a topic than a queue? We have another offering which is a publish-subscribe model called Simple Notification Service, SNS, and that's delivery to many concurrent clients. This is put it in a queue and multiple clients can bang away at it, and we will guarantee at least once delivery to one of those clients. Not exactly one. It's hard to make anything exact make it truly scalable and exactly one. So we guarantee at least once, but your application should be able to handle the occurrence of two things possibly grabbing the same item from the queue. So the anti-patterns for this is binary data. This is text only, data that's larger than what fits in a single message, and something that needs durability beyond that 14 days. But if you can live within that, especially in conjunction with data stored in S3, it's really very useful. Last category is backup and archival storage. So the first of these, and the most important really, is EBS Snapshots. When you create an EBS volume, built into that, you get the ability to click on it and say, create me a snapshot of that volume. And it gives you a point-in-time backup of the contents of the blocks of that disk, and then we'll represent those as a sort of delta series of snapshots. Each one represents a complete backup. So you can restore a new EBS volume or multiple EBS volumes from any snapshot, and it gives you more than just backup capability. It gives you the ability to clone a volume in a different AZ. Yes?
I guess I'm confused. In those first two subdots, there says only the data changed. The next one, the phase 2 snapshot represents a complete backup. It seems to contradict.
What it means is that we manage the data under the covers, and that they're sort of logical restore points. So in terms of the amount of data that we store, each time you click the snapshot button, it's only the data that you've dirtied since the last snapshot. If you choose to erase all the previous snapshots, you don't have to worry about it. We'll simply roll that data into the representation of that most previous snapshot, because everyone represents a full restore point. So this gives you a way to kind of manage your EBS volumes at the region level. This gives you the ability to clone a volume that lives in one availability zone into another. It gives you the ability, like we talked about previously, to resize a volume. Also gives you the ability to share it between accounts. So you can give another account the ability to create a volume from your snapshot, for example. Next one is one we've talked about already, but S3 is very useful as a backup point. The things that make S3 very suitable as backup storage is this extreme durability. So under the covers, what we're doing is we're detecting bit rot and repairing it. So if we lose any redundancy, we will automatically bring that back so that you have that sort of equivalent of 3 full copies. So that kind of gives you protection against the sort of natural bit rot of data. We also give you a versioning capability and the ability to allow it only to be deleted if you use a multifunction authentication device, like the equivalent of an RSA key, if you will. Most data loss is really fat finger, unintentional deletes. So this gives you, entropy protection and human entropy protection, if you will. So see if your tape backup library will do that for you. It's highly secure. We've talked about this in other areas, but you can encrypt in flight. You can encrypt at rest, both on the server side and the client side. And we give you this very rich access control mechanism so you can control who can see the data and when. And you can log it all. So it really is ideal for backup that is off-site, extremely durable, but always live. And on final note, an adjunct service that's useful for both EBS Snapshots as well as S3 buckets is our import-export service. This is kind of a virtual sneaker net. It's a send-us-a-disk model. You put your data on disks, we'll dump it into the bucket of choice or the snapshot of choice. So it's a way to bypass the internet and move massive amounts of data in or out. So ideal use case is sort of general, loading of data as well as off-site backup and disaster recovery. And that's, I think I managed to almost finish on time. If you remember three things out of this pitch, the first and most important is EBS as primary storage for your databases and files on an EC2 instance. If you use EBS, snapshot your data because that will give you the durability of S3 with the utility of EBS. And the last one is S3 if you need extreme durability and constant access to your data. Last questions?
Can you talk a little?
Yeah, I'm not, I think it is AES as the underlying encryption standard, but I don't remember the key length, so it's something we could probably take offline. Well, in general, it's the same concept, not quite the same implementation. It's more of a policies and procedures that we don't look into the contents of the bucket unless we've got a court order of some kind saying turn over the data. And the real protection against that is to encrypt it before we see it. And that way, if we see it, protect against the sort of rogue employee or some government turnover order or a court order. If it's encrypted, we can give them the data, but it is of no use. And that's really why we support both the client-side encryption and the server-side encryption. But access from with RDS, it's a little trickier. RDS does not support whole disk encryption at this point in time, but in the database libraries, you can not encrypt the key, but encrypt the contents of the rest of the record, that sort of thing. It's kind of the only thing that you can do at the database level. Yes?
About 5 slides ago, taking frequent snapshots in EBS volumes for durability.
Yes.
Can you explain that a little bit?
Yeah, the EBS, so the question is explain why take frequent snapshots for durability. And actually time's up, but I can continue answering the question if you like. EBS will store data on 2 mirrored copies of a volume, and then if you take a snapshot, we will store the whole contents of that volume or in a series of, the first snapshot would be the whole contents, subsequent would be just deltas on that. And that gives us basically more than 3 places to find data in the event of some kind of a disaster. So if we were, so your 2 volumes, your 2 mirrors are on 2 different servers, 2 different sets of devices, it is theoretically possible for us to lose both of those simultaneously. If we have a snapshot to go back to, we can generally restore your volume. Okay. All right, thank you.